synthesis of some heterocyclic compounds. Especially in this class, we are discussing the synthesis of pyrrole and also furan. In the next class, we will study the synthesis of pyridine, which is usually asked for 5 marks. So here we will have some 2 marks questions, very small preparations. So we'll see the synthesis of first furan from 1,4-diketones. 1,4-diketones. We have many types of preparation for this furan and also pyrrole, but this 1,4-diketones, from 1,4-diketones, which has been asked many times, so that's why we'll just restrict it to the preparation of furan and pyrrole from the 1,4-diketones. So just for your reference, 1,4-diketones, yeah, here you see with respect to first position and fourth position, if I put 1, 2, 3, 4, at first and fourth are first position and fourth position we have ketonic groups. So these compounds are known as 1,4-diketones, and these are also showing some transformations. So they are dynamically equilibrium with tautomerism, that is showing keto-enol tautomerism. So this ketone group can be converted into enol, so that's why they show some keto-enol tautomerism. So when this occurs, so one of the hydrogen from here will donate electron and that shift to the oxygen, it gets the O minus and this H attacks here. Here the same thing, one of the H will give electron and it electron shift to the oxygen, it becomes O minus and H attacks here. So this will become OH, this will become OH, these two will become double bonds. See here, CH, CH, double bond, COH, R, COH, R. Okay, these are known as same compound, 1,4-diketone, but it is in the ketonic form, and this is in the enolic form. Enolic form. It has double bond ene and alcohol groups ol. Enolic form. So this enolic form is very important for the preparation of diketones. So if you take that enolic form of 1,4-diketone, yes, this is 1,4-diketone. This is in the enolic form. Which usually undergoes dehydration. Okay, when it undergoes dehydration, obviously dehydration by heating in presence of phosphorus pentoxide or even sulfuric acid, concentrated sulfuric acid, it undergoes dehydration. Here water molecule will be released. So one of the AH and OH will release. So now it becomes CH, CH, double bond C, double bond C, R, R, this become O. This is nothing but a derivative of phenol. So it is 1,4-dialkyl. Now we can say 1,4-dialkyl furan. 1,4-dialkyl furan can be prepared. This is a very simple method that usually asks for 2 marks in your exam. But if you want to synthesize pure furan. So here no, we do not need any alkyl derivative. Then we have to replace this R with H. CH double bond, sorry, CH double bond C double bond C H H. This is OH OH. This is nothing but succinaldehyde. This is succinaldehyde. Succinaldehyde. But it is in enolic form. It is in enolic form. Please remember, sir, you can say, you can ask me like there is no aldehyde, sorry, ketonic group or aldehyde group, sir, but you are writing, actually there are alcohol group, but you are writing aldehyde. Actually it is aldehyde, but it is in the form of enolic. It will be like this. Okay, here if you replace with R by H, that is a succinaldehyde. So this succinaldehyde also, when it undergoes dehydration, okay, so here we can take a temperature around 160 degrees centigrade. It undergoes complete dehydration. Same in presence of phosphorus pentoxide or sulfuric acid. Here also dehydration takes place and it gives us furan. CH single bond CH double bond C double bond C O O. This is our furan. We can get the furan directly from succinaldehyde. Succinaldehyde by the dehydration in presence of phosphorus pentoxide. This is a very simple method which you usually ask for 2 marks in your exam. Okay, I think you will get it. So if you take general diketone, 1,4-diketone, you will get a alkyl derivative of furan. And if you take a succinaldehyde, an example of 1,4-diketone, then you will get the furan as the product. So you can write from here the synthesis. Okay, so this is what happens before the reaction. I am just representing over here. So this is it is always in dynamically equilibrium. If you find this ketonic form, it will be enolic form. Both are always in dynamic. Both are 1,4-diketones. They are not two compounds. Sorry, not both. They are not two compounds. This is only one compound that present in both the states, physical states. That is isomerism. Thiophene can also be synthesized from 1,4-diketone in the same way as furan has been synthesized. So here, same 1,4-diketone. Okay, as you know, it undergoes keto-enol tautomerism. So this enolic form, okay, this is a 1,4-diketone in its enolic form. This is in ketonic form. So the same compound, if it dehydrates, when it undergoes dehydration with phosphorus pentoxide, then it gives us furan derivative. If it undergoes same dehydration instead of phosphorus pentoxide, here I am going to take a phosphorus pentasulfide. Phosphorus pentasulfide. If you have oxygen, if you need oxygen, we will take oxygen. If you need sulfur, then we will take sulfur. Phosphorus pentasulfide. Phosphorus pentasulfide. Okay. In presence of phosphorus pentasulfide, this 1,4-diketone undergoes dehydration and it gives us the thiophene. Thiophene derivative. So it is the thiophene derivative. As usual, at first and fourth position we have disulfide. That's why it is alkyl groups. So it is 1,4-dialkyl thiophene. As usual, if you want pure thiophene, then we have to take, instead of this general compound, we have to take a specific compound, that is CH double bond C, here H OH. This is succinic dialdehyde. Sorry, in the Furan I have written succinic aldehyde. It was succinic dialdehyde. Please make correction yourself. So succinic dialdehyde, the same compound, when it undergoes dehydration in presence of phosphorus pentasulfide, so it will be, I think, it just need 100 degrees centigrade. So here now we will get the thiophene as a product. We got the thiophene. So same furan and thiophene can be synthesized, this 1,4-diketone from 1,4-diketone. The only you have to replace the dehydrating reagent, and here we will take phosphorus pentasulfide. In the case of furan, we have taken phosphorus pentoxide. So this is about the synthesis of thiophene from 1,4-diketones. In the same way how furan and thiophene could able to synthesize from 1,4-diketone, the pyrrole also can be synthesized from 1,4-diketone. So let us see that. So this is 1,4-diketone. It is in ketonic form. As you already know that it is showing keto-enol tautomerism. It is dynamically present in another form or another isomer, the same compound, that is the enolic form. This is the enolic form of 1,4-diketone. One comma 4 diketone. The same way here also it undergoes dehydration, along with it is treating with ammonia. Okay, it undergoes dehydration, and also in presence of ammonia it gives us the derivative of pyrrole. This is pyrrole. So it is, as usual, one at first and fourth position we have alkyl groups. So it is also 1,4 dialkyl pyrrole. 1,4 dialkyl pyrrole. The same way, if you need to prepare the pure pyrrole compound, we again have to take the succinic dialdehyde. This is succinic dialdehyde. It is in the enolic form. enolic form. So it undergoes dehydration about 130 degrees centigrade, and it is treated with ammonia, will give us pyrrole. Will give us pyrrole. Will give us pyrrole. So using succinic dialdehyde, an example of 1,4-diketone, when it undergoes dehydration and treated with ammonia, will give us pyrrole. So these three compounds, thiophene, furan, and also this pyrrole, can be synthesized from 1,4-diketones, one of which may be asked in your exam for 2 marks. This is a very simple and important method for the preparation of these 5-membered heterocyclic rings. This is also industrially applicable and industrially used, employed method for the preparation of 1,4-diketones. Thank you. Thank you for watching my video. Please like it and share with your friends, please, and subscribe my channel. Thank you.